So here at the farm we have a lot of different outputs. Of course the farm itself produces feed products like rice, wheat or barley, corn. With the plant we have an output of electricity and methane, and also we have an output of digestate that, as I said, is a natural fertilizer. So as a farm, as a modern farm, we have a lot of different output from the feed and food production, the electricity production, but also fertilizer. So a scheme of different output, all synergy connected. The energy, electricity and the gas we produce is clean, so we help, for example, around 200 average house, both from gas and electricity year supply to use green power. Also, we save a lot of chemical fertilizer. So there's a huge impact, positive impact on the community in terms of reducing the emission. I'm very pleased to have you here today. I will show you our plant that is quite rare in Italy, because it is one of 8-10 plants that produce both energy and methane gas from agricultural only byproducts, not biomass but mainly byproducts. First of all, we are in a farm, so we are mainly farmer, but we have developed it through the year. The first plant is from 2012, and the latest plant that is here is from 2020. The first thing that I would like to show you is the plant that is in front of us, that is called economizer, that is able to treat a specific kind of biomass that are like straw, corn chop, or every kind of straw, like from rice, wheat, barley, and this allowed us to use this kind of biomass for the biogas production. Is a particular technology that is called steam explosion. The plant works with a very high temperature and very high pressure, and is able to disgregate the fiber of the straw. And this plant allowed to produce us around 15 tons per day of a very high quality biomass that goes into the digester. So as you will see, we will have three main categories. The first one is the byproduct of the farm. These are all treated through this plant. I will show you the other category. This is the second station I show you, is where we collect the product that comes from the cow and chicken and all this kind of activity. For example, on the right you can see the product that we collect from our eggs production plant that we have in the same site. Is the one that you have seen maybe at the entrance and in the north gate. And we have 60,000 chicken producing, so we collect all we call in Italian pollina. In the back we have instead the ordinary cow manure, and our farm only produces chicken, so all the manure that you see comes from a network of other farms here around that sell us the manure. Sometimes it's paid, or sometimes it's exchanged with the digestate, so the product that we will see at the end. So the first station, as I show you, is the byproduct like straw. The second station is the manure. The third station, that is this way, is the byproduct from agro-industrial transformation or activity. So the cows are not in this farm. It's a network of mainly 4 farmers that have in total more than 10,000, because there are 2 big farms with 5,000 each. To give you an idea, we process 15 tons per day of straw, 10 tons per day of chicken, 10 tons per day of manure, cow manure. So more or less the overall quantity, including the last station I will show you, is around 50 tons per day. We would like to explain is that we are seeing mainly byproducts here. That means that are not in conflict with the food production. The farm continues to do their core business, that is the rice production, the wheat production, barley production, or also corn, for example, production. That goes for the feed or food destination. Plus, we collect all the byproduct that this cultivation produce, like the wheat or the manure, and we use them to produce energy. So are an activity in parallel. So there's not anymore a huge conflict between the feed production, the food or feed production, and this kind of plant, and is a full synergy between the two activities. This is a crucial aspect that I would like also to express to you more at the end, when we will understand also that everything that goes into the plant comes back to the field. So the circular economy is very strict from this point of view, because we collect the byproduct of the agricultural process, so we can say the waste from certain aspect, and also we provide the input of the new cultivation, because the digestate that we will see at the end is used as a fertilizer. So is a continuum integration between the farm and the plant, and the synergy between them. Our farms mainly produce what we are seeing, but there's a network of farmers that give, for example, a certain part of straw we buy outside, a certain part of manure we buy outside, and so we help them to end this byproduct that otherwise sometimes can be a cost for them to manage. Plus, we give them the possibility to receive the digestate that I will show you at the end, that is a sort of compost that help them to reduce the chemical fertilization, and so there's a synergy also for them. Mainly that our farm is involved in this mechanism, but it's open also to certain partners here around. Methane is expressed in cubic meters, is 400 per hours, that more or less is like 2 electric megawatt per hour equivalent. The plant work day and night, every day of the year. You can consider along the year around 5% of stops for maintenance, something planned, something not planned, or this kind of. So if you do 24 per So this is the third station that I show you. Is divided between a few slots because we process different product. For example, at the moment we are working with the chocolate and coffee industry. For example, this is our pieces of chocolate and coffee processed. For example, maybe this one you can recognize, the coffee bean, I think. So when they produce and they process the coffee or chocolate for the industry, they also produce an organic waste, and this is very good too also for the biogas production. So they are very happy to sell this product to us, because they don't have to throw away in different way. But we are also very happy because it's a very good product with a part of grass, of oil, so it produces quite a good amount of gas. And this is just an example. We can say that mainly every kind of organic organic waste can be processed accordingly to produce biogas. So this is an example. Here beside, we don't have at the moment the product, because as soon as arrived we put inside the digester, but this area is designated, for example, to pizza preparation, the liquid that you, in Italian it's called impasto. I don't know.
It's like water and
water, flavor, yes. So you can imagine that once a week, twice a week, a truck comes here and collect around many factories that produce industrial pizza, and here comes the byproduct. There are very different situations, because at the moment the byproduct have a good market for who sell. So we buy, we pay, but we have to consider that the price is not connected to the food connection, but is mainly related to the capacity of produce biogas. So we do an analysis when the products arrive. We estimate the methane yield, I think, yes, and there's an agreement with the linked to the potential. So as much as the quality in this perspective is good, the much we can pay. So to give you an example, we have product like the manure that is very cheap, that is around €1 per ton, but we have very expensive product like maybe this that is 80 euros per ton, because have a very high potential. You can consider that this product is comparable to manure like in a ratio of 1 to 5, so much higher. And the consideration of this area is that the farm can help also agro-industrial operation to not throw away product, but to sell, or to at least give to us in order to be valorized as a biogas biomass. It's like a bread byproduct. So it's bread that is not reliable for food, or for many reasons we cannot know. But sometimes also this comes through to the plant. Okay. I show you quickly. This is the part when where the gas is produced. So you consider that the 15 ton of different material that I've shown you comes into the digester. I give you a quick image. The dome, I don't know if you call the roof, is not hard, but is being, as you see, is pressed by the biogas production. So what keeps the dome so yes, is the fact that there's a gas production under it, and it's also used to storage a little bit of gas. So we have the dimension is a concept in order to hold at least for 6 months the biomass inside, but the biogas production is very quick, so you can consider that in 10 days on average, from when the certain product is inserted in the digester, and in around 10 days we express all the potential. But we keep for a longer period also to collect the curve of maybe 5% that is given in a little bit longer time, and also we have so long capacity in order to manage from a logistic point of view. Of course, you cannot every day move this product. So, sorry. We have seen the biomass. We have seen that it goes inside the digester. We are in the composting plant. So all the biomass that goes inside the digester, at a certain moment, as I said, they have to go out. When they are ready to go out, are sent through this plant that is a composting plant. So the liquid that you are seeing that is being distributed is coming directly from inside the digester. Every day we distribute around 30 to 40 cubic meter of digestate into this plant that is mainly set with a certain amount of dry material as chopped wood, grass or straw, this kind of dry vegetal material that are not suitable anyway for the biogas production, so are dedicated to this plant. The plant also mix the product and inject also hot air. This is why you see also the smoke. Okay, it's because the mass is actually around 50 to 60 degrees. That's why. And this helps us to transform the liquid digestate into a solid product. Also help us to make it with good, with better quality and higher fertilizer product power, with higher standard of stability, like the pH. I don't know if you, okay. We are switching a bit to an agricultural technical side of the situation. So what is mainly interesting to understand is that this plant converts the liquid into solid. Why is it so important? Because if it's solid, it's much more cheaper and easy to transport. So you can put on a truck and do the transport in a much easy and comfortable way. But it's not the only way to handle the digestate. You have to consider that from the plant there's a pipe that is 1.5 kilometers long that pass through the farm, our farm, and we are able to connect the tractor through a rope, I don't know how to say, to a pipe. So as long as it's working around the field, is also injecting the digestate in the field. So you never see the digestate is working, is moving on a pipe under the fields. There's some points where there are like attachment, and through a pipe the tractor. I can show you maybe a quick video just to understand if you maybe have not seen before. It's like this. Okay. There's a tractor with a pipe under. Okay. You can consider that in a span of 5-year times, maybe also the color and the texture of the soil change, and this is very helpful when you have to work, to plug or whatever the fields, and also the capacity to drain water, for example. There are many aspects. We do every 3 years like an analysis of the fields, and we have seen that the main elements like potassium, phosphorus, or this kind of main elements are increasing, stably increasing, and this is very helpful also in a long-term perspective, because due to the evolving of the fertilizer market is getting much more expensive, and also like in situation as the biological cultivation is very appreciated. So it's a strict connection between the plants. So this is an Italian plant, Italian manufacturer that is present at EIMA 2, if you're interested to visit. This seems a quite easy plant, but it's not, because is happening a certain type of process, of biological process, through the humidity, the temperature. So the machine is quite easy, as you see, but the process going on have as well some parameters, and this company also help us in produce a good organic fertilizer. So it's not just the machine, but it's the know-how in the process, in the composting process. So temperature, mixing of dry and liquid, and this kind of thing. Also the analysis at the end, in order to understand how much and how to use on the field. There's a lot of know-how in managing the compost more than in the machine itself in this case. I've seen that the biogas plant is in German manufacturer. The steam machine is in Austrian manufacturer. So we have arranged the best available technologies, but all the connection and the infrastructure that connect all this is, we can say, made in-house between our experience, our technician, and this kind of thing. Step, just to explain that all the heat that is needed through the process is mainly recovered by the other plant. So the straw treatment works at 200 degrees. The refinery of the biogas work around 100 degrees, and the biologic is around 50 degrees. So consider a huge amount of heat that is required, but we are able to recover it. These pipes come from the other plant, where on their engine we do a heat exchange on the gas. So this is all, let's say, heat that we save. Through this pipe we distribute it through the different plants to do the process. So the heat, you can consider, is 80% recovered, plus we have solar panel on the roofs here around. So also, let's say, 35% of the energy is produced through solar. In the last step is where the biogas is refined into methane. You have to consider that the biogas, when it's raw, have around 55 to 60% of methane inside, and this plant, that is in Italian technology, is able to refine the biogas. So there's a treatment that helps with the temperature, chemical reaction, but gives back a very high quality methane, up to 99% methane. The yellow pipe that you see for just a meter, then go down, is the exit of the process. So into the yellow pipe is passing pure methane. There's then a main pipe that is owned by the state, that from the field goes this way, that were present also before we have done the plan, and that goes through different cities like Ferrara, that is the main city here around, and supply the gas and then connect. The pipe goes from Ferrara to the sea. I don't know if you have seen the maps, but we are around 10 to 20 kilometers from the sea in this direction. So there's a main pipe that comes from the Ferrara and connect all the cities along this way through the sea. And we produce the gas methane, not the liquid, because you know that there's the both possible, is just the compressed one, and so helps. I can give you few idea of the capacity. It's 400 cubic meters per hour. That if you consider an average house, it's used 2,000 cubic meters per year. So we can say that more or less in 5 hours we are able to provide the 1 year amount of gas for an average house. Or you can consider that with 400 cubic meters you can refill 20 to 30 cars, so 20 cars per hour. So the quantity for sure, not in a world scale, but is a local scale, is very interesting for sure. And I think that this plant are maybe seems small quantity compared to what other situation can produce, like nuclear plants, if you talk about electricity, or Gazprom can send if we talk about the gas production. But in a local scale, these plants are very significant, both in the circular economy, so help not to throw away organic waste, help to give back to the field organic fertilization, and to produce, of course, the main output, so electricity or gas, in a consistent, in a relevant help for the local economy. So if you have to look to this plant for sure in a local scale, local economy, and so they will be really very relevant to your eyes in this perspective.